Okay guys, so now let's take a look at the example at the section 4.2 more specifically, and let's try to apply what we just seen in this combined 4.1, 4.2 section, the previous videos. So we have to find a vertical asymptote for the example number 1. If I want to find a vertical asymptote, I need to define where the denominator is going to be equal to 0. So if I look at my denominator right here, x minus 2 is going to be equal to 0, imply that x is going to be equal to 2, and that is going to be my vertical asymptote. Okay? Now, in the other hand, if I look at the b, I realize that what I have is x squared minus 5x plus 6 equal to 0. And if I want to find the vertical asymptote, I need to solve this quadratic equation. To solve the quadratic equation, I can right away factorize, or I can use my quadratic formula. In that case, I'm going to right away factorize. Because it's a degree 2, I'm supposed to have two parentheses. I have plus right here and right there. So now I put a plus and I put a plus. You will notice that I decided to put on my own a plus in between the x squared and minus 5x, because like this I will know for sure that inside my parentheses I will have only plus. Like this I don't have to deal with, do I have a minus, do I have a plus? It will be always plus. Then I have to have an x and a x, because the multiplication of these two terms, x by foiling, you end up to have x squared. Then the last term has to be a 6, so there is two possibilities for the 6. It has to be 2 by 3 or 1 by 6. If I decide to take the 1 and a 6, I'm getting a plus 6, but I need to have a minus 5. And the only way to have the middle term equal minus 5 is to have a negative 6 right here. Because now I'm getting a x squared right there. I'm getting and I need to have, do I need to have a minus 1 right there? Because I'm looking for a plus 6. So that is not good. Alright guys, that is not good. I just realized that by doing this, when I'm checking my middle term, I end up to have, I was so focused on the middle term that I did not realize that I was supposed to have a plus 6. And if I have a minus 1 and a minus 6, I have a plus 6, but now my middle term is my middle term is going to be a 7x. I don't want that. So I'm going to erase this, okay, and do it again by just changing few things. First of all, I still have x plus and I still have x plus. But if 1 and 6 is not functioning, I'm going to use a 2 and a 3. Okay? And if I'm using a 2 and a 3, with negative 2 and negative 3, I'm getting a plus 6 for the last term. This one is going to give me a plus 6. The term number x by x give me x squared. I'm alright with that. And then the middle term is going to be minus 2x and minus 3x. Minus 2x and minus 3x give me minus 5x. So I end up to have, at the end of the day, a x plus negative 2 equals 0, so x equals 2, and a x plus negative 3 equals 0, so x equals 3. And now I have my 2 vertical asymptote, x equals 2 and x equals 3. I got 2 vertical asymptotes. Don't forget what you need to remember when you want to try to find the horizontal asymptote and the oblique asymptote. Okay, you need to know the different cases we've seen before. Case number 1, case number 2, case number 3, and case number 4. Depending on what you have to deal with, you will find the value of the expression of the horizontal asymptote, oblique asymptote, or the fact that you have an oblique asymptote. So I'll let you solve the example number 2. Just look at the example number 2 right away. It will be easy to say that you have the same coefficient. On the top you have a coefficient 1, and the bottom you have a coefficient 2. So let me try to tell you that. The numerator, you got a term to 1 when your denominator is 1. On the B, you got a numerator that your degree is 1 when the denominator is 2, because it's 2x squared, so the square gives you the degree of your denominator. And for C, you got a numerator this time equal 2 when your denominator equal 1. So apply each case and you will find the definition, the horizontal and oblique asymptote. Try to graph with your calculator the different different case for the example number 3, and try also to find by hand the expression of your oblique asymptote, horizontal asymptote, or vertical asymptote if they does exist. Okay? I think I'm pretty done with this section 4.2, specifically 4.2. Please apply this definition. It's just a question of applying the definitions, and talk to you in class. Thank you.